The radio is one of the outstanding developments of the 20th century. With modern radio sending and receiving equipment, it is possible to establish communication instantaneously from any place at any time. The radio brings into the home, the schoolroom, the hospital, and the office music by leading artists, drama by outstanding actors, speeches by men in public life, and news of world events, together with weather and market reports. Commercial and military aviation depend on radio. The radio operator communicates with other planes and with ground bases. Radio principles are also used in blind flying on a radio beam. The Coast Guard and the Navy, in their constant vigilance, are guided at all times by two-way radio communication with other ships and with their bases of operation. Army tank operations are directed by radio. The tank commander is in radio communication with the tank crews under his command, as well as with the field headquarters. Likewise, every unit of the Army uses portable radios to receive orders from and send information to their command posts. Let us follow through the steps and the processes in transmitting or sending radio messages. First of all, the sound waves produced by the announcer are picked up by the microphone, which is one element in the transmitter circuit. This circuit requires a source of electrical energy, shown here as a primary cell. The moving particles represent electrons as they flow in a direct current. All sound sources set the molecules of air into vibration in such a manner as to produce waves which travel through the air. In the radio studio, these waves strike the diaphragm of a microphone. As the molecules in the sound wave move back and forth, they set the diaphragm into vibration. In the carbon microphone, each time the sound waves push the diaphragm in, it presses upon a mass of carbon granules and reduces their resistance to the flow of electricity. Thus, more electrons can flow in the circuit. Each time the diaphragm moves out, the carbon granules separate. The resistance to the current is increased. Now, fewer electrons can flow in the circuit. Thus, in the microphone, the movement of the diaphragm regulates the flow of electrons in the transmitting circuit and changes the steady direct current into a pulsating direct current. Although most sounds are complex, we are illustrating this voice current as a pure tone. At the top, we now trace out a curve to represent the pulsating direct current. All these processes are slowed down in these animated drawings in order to show clearly how the electrons move in the circuit. In this schematic transformer, the primary coil, which is a part of the transmitter circuit, is at the left, and the secondary coil is at the right. As the current increases in the primary coil, it builds up a magnetic field which sweeps across the loops of the secondary and starts a flow of electrons. When current in the primary decreases, the magnetic field collapses and the lines of force cut back through the secondary coil. Now electrons in the secondary flow in the opposite direction. When the magnetic field builds up, the secondary current flows in one direction. When the magnetic field collapses, the secondary current flows in the opposite direction. A current which flows in one direction and then reverses to flow in the other direction is called an alternating current. At the top, we now trace out a curve to represent the alternating current in the secondary. When the curve crosses the zero line, it shows that the current is changing direction. The monitor in the control room controls the quality of the sound as it goes on the air. The monitor balances the sound from the various sources to achieve the desired blend. The voice current, or the audio frequency current, as it comes from the transformer, is amplified by vacuum tubes, such as these. Let us retrace the main events in the audio frequency circuits. The microphone brings about a pulsating direct current. The transformer changes this to an alternating current. Vacuum tubes amplify this alternating current, which then goes to the modulator tube. The broadcasting station uses a high-frequency current called the carrier wave to transmit the message. A generator supplies a direct current to the oscillator tube. The oscillator tube changes this direct current to a high-frequency alternating current of several 100,000 cycles per second. The box below this oscillator tube contains a quartz crystal which keeps the carrier wave at a constant frequency. This radio frequency current also goes to the modulator tube. This is the modulator tube, in which the radio frequency current is modulated by the audio frequency current. In the modulator tube, the audio frequency current shown at the lower left modifies the radio frequency current shown above according to the strength and the frequency of the voice current. This is called modulation. Note, however, that the modulated wave is still a radio frequency current. The modulated radio wave now goes to the power tube. This is the primary power source of the transmission station, where current comes in at a high voltage. These transformers convert the incoming current to a high voltage necessary to secure dependable long-range sending. These vacuum tube rectifiers convert this alternating current into a direct current. Power tubes operating on this high voltage are used to amplify the modulated waves received from the modulator tube. Several power tubes are used when great sending power is desired. The current from the power tubes goes to this antenna coupling unit, which is essentially a transformer. The current is carried by two insulated copper tubes, one within the other, to the antenna. To review the events, the modulated radio frequency current coming from the modulator goes to the power tubes. The power tubes amplify this current, which then goes to the antenna. This antenna consists of two steel towers and a central wire supported by a cross cable between them. Radio waves are sent out in all directions. Thus, from the power tube, the modulated radio waves go to the antenna. The radio messages leave the antenna as electromagnetic waves and travel out into space with the speed of light. For special events, this portable device broadcasts by shortwave to a local station for rebroadcast, or it may be even used as a receiver. Let us recapitulate the events in radio broadcasting. Sound waves strike the diaphragm of the microphone. A pulsating direct current is set up in the transmitter circuit. This is changed by the transformer to an alternating current, which is amplified and sent to the modulator tube. A generator delivers a direct current which the oscillator tube changes to a high frequency current, which is fed into the modulator tube, where it is modified by the audio frequency current coming from the microphone. The modulated current is boosted by the power tube, which is coupled to the antenna. Here the radio frequency sets up electromagnetic waves, which travel out into space with a speed of 186,000 miles a second. When these waves strike the antenna of a receiving set, this entire process is reversed. We hear sound originating at that very moment, hundreds or even thousands of miles away.